Hey kids, Alanator here, and it's Chapter 1, Functions, Graphs, and Limits, and today we're working on 1.4 Functions, Section 1.4. So we want to decide whether the relationship between two variables is a function. We want to find the domain and ranges of functions, and we want to use functional notation and evaluate functions. Then finally, we want to combine functions to create other functions. And oh yes, find inverse functions algebraically. So it's a lot, so I'm going to try to do 2 videos for this. So the definition of a function is a relationship between two variables such that each value of the independent variable, and very commonly we use x for that, corresponds to exactly one variable, the dependent variable. So very many times we say that that is y. The domain of the function is a set of all values of the independent variable for which the function is defined, and the range of the function is a set of all values taken on by the dependent variable, and again, y. So when we look at this, you often see these machines, function machines, if you will, where you have the domain, then it goes in as the input to a function. Some kind of operation is being done inside this machine, and the output is then, of course, y. So if we consider the function 4x squared plus 3, the order of operations will be handled as follows, where we would first then square the x, right? Square the x. So we'd have x squared. Then we multiply the x by 4, so that gives 4x squared. And then from there, then we have 4x squared plus 3, where we're going to add 3, and then we get our expression for y. So our machine operates on x to produce a function y in terms of x. Okay, so you have let me scroll this down. So you have a warm-up. Why don't you do those 4 warm-up problems, and then when you're done, come back and check your answers. Pause the video and do the problems and check your answers. So here we go. Since the time has elapsed and you've done the warm-up already, these should be the answers that you would get. The couple cautions here, when you're squaring a negative number, when you're subtracting a negative number, those are all potential problem areas for students. So be careful, be cautious when you're using order of operations. And then over here on number 2, you have a negative sign in front of a grouping, so you have to distribute the negative to both the 1 and the negative x, giving you minus 1 plus x. So for your final answer, you have 1 over x. And then for number 3, I'm going to solve for y, so I want to isolate where the y is in the expression, which is right here. So the first thing I do is multiply both sides by 4, which cancels the 4 in the denominator on the right. You're left with 2y minus 1. You're going to add 1 to both sides. So you get 4x plus 1 is equal to 2y. And then the last step is we're going to divide by 2, giving us our final answer here. And then for number 4, we're solving for y, noting that the y that we're trying to solve for exists in a factored quadratic binomial squared. So in order to get to the y, we're going to take the square root of both sides. And a convenient time for me to talk about this idea of what is the square root of something squared. And it's actually the absolute value of y minus 3, the quantity that's being squared. Now what we typically do, though, is we take the y minus 3 and we just say is equal to plus or minus then. So many of you go from this first step down to the third step pretty quickly and avoid the second step completely, and that is fine. But understanding why it is, because you're taking the square root of a number that's always going to be positive, a square number, a perfect square. So your answer is always going to be positive, but y minus 3 could possibly present a problem because maybe y could be 2, and 2 minus 3 is negative 1, so you don't want that in your set of solutions. So here, the last step is you add 3 to both sides, and we can leave our answer like that. Now, sometimes people get confused because they see something like this, 9 plus x squared, and you have to remember that there's a tendency to say that it's not equal to 3 plus x, but we sometimes want to do that. It's not the square root of 9 plus x squared is not equal to the square root of 9 plus the square root of x squared. It just is not. So, okay, just wanted to say that. So notice how we leave our answer in that one. Okay, so moving forward, talking about functions, are equations functions? So we see equations all the time. So let me go to a black pen. So to recognize that, we can usually tell when it's solved for y. So we're going to isolate our function, our equation, and we get y is equal to negative x plus 1. And yes, this is a function, we know this well, as a linear function. Okay, and then for the next one, we have y squared is equal to 1 minus x squared. But we're not really solved for y yet, so I'm going to solve for y to get y. So I am going to, by itself, so I get y is equal to plus or minus, again, just going right to that plus or minus 1 minus x squared. So you notice that for each input x, we have two outputs for y. So this one would be no. And we can say it simply. We don't have to say it in very strong collegiate words. No, each x is assigned two y's. Here, gets two y values. Okay. So then the next one we have y is equal to negative x squared plus 1. So this one is, and you know this is a quadratic that's concave down, so it kind of looks like this, right? So you know that shape, concave down with the y-intercept at 0, 1, right? So the answer here is yes, it's a quadratic function. Okay. And then for the last one, we have y squared is equal to negative x plus 1. And again, solving this one for y, taking the square root of both sides. So we get y is equal to plus or minus, and I really like to put this one like so. So again, we have that same issue with the plus or minus here when we solve for y. So this one is going to be no, and the same is b. Okay, so we have a yes, no, yes, no. Okay, so now with this next one, we're going to use what's called interval notation. Hope that was, so very often we can tell when we read, going back to this previous one, example 1, we can very often tell if it's a function based on the form of the equation. When we solve it for y, it's much, much easier to tell. So we could tell with b and d that absolutely not, those are not functions. So now with the next one, we want to find the domain and range of each function, and we use inequalities and interval notations. I think my decision was to go ahead and use just interval notation, but I want you to be familiar with both. So on A, I'm going to do both. B, I'm just going to do interval notation. So recall that we have brackets. We use parentheses when we include the endpoint and of the interval, and we use brackets. I'm sorry, I said that backwards. We use parentheses, highlighted, parentheses when we don't include the endpoint on an interval, and we use brackets when we do include it, the endpoint of an interval. Okay, infinity is never included, but here we go. So the domain, all the x values that we're using here are when x is greater than or equal to 1. And then the range, that's the domain. So we're using all of these values. Okay, so that would be the domain. And then the range, I'll use a different color here. The range would be all of these values. So on the y-axis. So the range then would be y is greater than or equal to 0. Now, in like manner, we can say that in interval notation, and you guys are familiar with this a little bit. So we would say, we would start at 1, and we would go to infinity and put a bracket. We would start at 0 here as the lowest value. It's where you start, where do you end? In this case, the interval notation, both of them go to infinity, so we put a parenthesis there. Okay, So that's the first one. It is a square root function. It's the square root of x transferred 1 unit to the right. Then for the next one, we have what's called a piecewise function. And sometimes it's a good idea when you see these. If you're not comfortable with them, get comfortable, understand what they're saying. If you look what I did on both of them, I marked down the domain in the first one, the domain going from x greater than or equal to 1, and then the range y greater than or equal to 0. I did something a little bit different with this one because you have two pieces to this graph. You have 1 minus x, which is a line, and that's when x is less than 1. So I marked on the x-axis all of the x values that are less than 1. Notice there's an open circle at 1. And then for the square root of x minus 1, I just simply filled in that point because the square root of 1 minus 1 turns out to be that point where they meet, and that's at the point 1, 0. So the two branches of the piecewise function join to make a continuous function. So the domain in this case is going to be, now if you look at, you've got to look at the blue plus the pink x values because that's the whole graph, the whole enchilada. So we're going to start at negative infinity because 1 minus x goes all the way out to negative infinity. With the blue, it keeps going. And then I'm going to end at infinity because the same thing is true as the square root of x minus 1. It's continuous and it keeps going off in that direction, the same way where 1 minus x goes in that direction. So the range then is going to go from 0, and we're including that point, so I need a bracket. So we have a bracket, we go from 0, and then we're going to go to infinity. So it's the lowest point is 0, and the highest point, the range here, the highest point is infinity. There is no highest point. Okay, enough there, right? Okay, you can pause and go back and look at it if you need to. Evaluating a function, you've got to recall this notation for functional notation, f of x, and you've really got to be comfortable with it as you move into a calculus course, but we'll try to move at a nice little pace here. So find the values of the function f of x is equal to 2x squared minus 4x plus 1 if x takes on these three values. So I've kind of laid it out for you. Is the function 1 to 1 is the second question. So now that there's some vocabulary there that comes up from an Algebra 2 class or a pre-calc, but we'll get to that. So what we're going to do is we're going to input each one of these values. So the input is x. Remember, the input is x. And then the output is going to be f of x, right? So what we do is we're going to input, let me make this a little bit bigger. So I'm going to input the x value in each of these, right? And so if you don't have a calculator, remember you're only working with the right-hand side of the equation. But functional notation is very convenient because we can state our x and our y value at the same time. So f of negative 1 is the y value, where negative 1 is the x. So we're going to pop in the negative 1 in here. In the same way, we're going to pop in the 0 here. And we're only going to work with, the right-hand side of the equation. So functional notation, you're only going to simplify the right-hand side of the equation. So we can say 2 times negative 1 squared, which is 2 times 1. You could write that out if you want, 2 times 1. And then it's going to be minus negative 4. So it's going to be minus a negative 4. And I'm just going to take my time here doing it by hand. So I've got a double negative in the middle, so minus a negative 4. And then I've got 2 times 1 is 2, plus 4 plus 1 is equal to 7. So f of negative 1 is 7. I think I'll just let you follow the work that's there. So when we input 0, we're going to get 2 times 0 squared, which is 2 times 0, which is just 0, minus 4 times 0, which is 0, and then plus 1. So our answer for this one is 1. Okay. When we input 2, again, only working on the right-hand side of the equation, so we get 2 times 2 squared. We'll move a little bit faster. It's 2 times 4, or 8, minus 8 plus 1. So interesting, right? We have two values So remember, if you have a function that's 1 to 1, each x gets 1 y, but that y can only be assigned to 1x. It's a little smaller. So in this case, 0 and 2. So 0, if I was considering this is the domain and this is the range, the x values and the y values, then if I take these two values, there is only one value for y. So 0 goes to 1 and 2 goes to 1. So that's, by definition of a function, it is a function because each x goes only to 1 y. But the 1, if you switch these, the 1 it's got 2 x values. So this function is not 1 to 1. And it fails what we call the horizontal line test. And you've heard of the vertical line test. That's the horizontal line test. So picture it like this. This is what the graph looks like. So at 0, we have a point 0, 1. And we also have another point where we have 2, 1. So if you consider, if we drew a horizontal line, it would pass through 2 points. Okay? So the function is not 1 to 1. 1 to 1 is kind of like a monogamous relationship between x and y. Each x gets 1 y for a function, but if each x gets 1 y and that y can only go back to the same x, then it's a 1 to 1 combination. So if each x gets 1 y and that y gets that same x, then the function is called 1 to 1. Now we can make a connection here with 1 to 1 functions and their inverses. Okay, we're going to end up with starting example 4, and we'll come back to this in the second video. We're just going to start it. We're going to say, okay, f of x is x squared plus 7. To evaluate the expression using another algebraic expression can be sometimes daunting. So what we want to do is really understand our algebra. Now, delta x is a thing that must, picture it like this. I want it to stay together. It's one thing. There's an x versus delta x. X is a variable. Consider delta x as another variable. Okay? So if we're going to input this, we keep the same rule. A function is a rule. You follow the rule. What does the rule tell you? It tells you to take your input here, square it, and add 7. So our input here is now x plus delta x. So this will turn out to be f of x plus delta x is, we're going to square this, but remember, some of you may want to do this, and this is fine. So where you FOIL it, you get x squared plus x times delta x plus x times delta x. So you have first, outer, inner, and then the last is plus delta x squared. So now we're going to take this up and we're going to simplify this. So this becomes then x squared plus 2x. We're going to add these two. 2x delta x. That's all that's a product there. Plus delta x squared. See, all I did was add this and get 2x delta x. Plus delta x squared, and then we have to add the 7 there. So we can't combine anything at this point. There are no like terms. So that's going to be our answer here. I'm going to make this a little smaller. Okay, so this is our answer for what is f of x plus delta x. F of x plus delta x can't be simplified. We're going to use it just like that. So I did expand it for a reason, and we'll go through that in our next video, only because I think I'm getting a little bit long-winded here for a video. And we'll come back to lesson 1.4 for Honors Calc.